Hello guys, and welcome back to the reactions. In today's lesson, we're going to look at the concept of electrode potential. Now, when a metal comes in contact with a solution that contains its ions, it acquires either a positive charge with respect to the solution, or it acquires a negative charge with respect to the solution. This potential difference between the metal and the solution that contains its ions is what is called electrode potential. Take for example zinc. When zinc comes in contact with a solution that contains zinc ions, the zinc metal acquires a negative charge with respect to the solution. This potential difference between a zinc metal or zinc rod and the solution is called the electrode potential of zinc. In the same vein, when copper comes in contact with a solution containing its ions, it acquires a positive charge with respect to the solution. This potential difference between the copper rod or copper metal and the solution is called the electrode potential of copper. Now, the electrode potential is usually a measure of the tendency of a metal to undergo oxidation or reduction, that is, to accept electrons or lose electrons when the metal comes in contact with a solution containing its ions. Electrode potential can either be oxidation potential or it can be reduction potential. When it is oxidation potential, the metal acquires a negative charge with respect to the solution that contains its ions. When it is reduction potential, the metal acquires a positive charge with respect to the solution that contains its ions. Now, electrode potential can be expressed under standard conditions. In other words, you could have what is called standard electrode potential. Now, standard electrode potential is measured at a temperature of 25 degrees Celsius, or which is the same thing as 298 Kelvin, and then a pressure of 1 atmosphere, as well as a concentration of 1 mole per dm³. So it means that the electrode potential under these conditions, under a temperature of 25 degrees Celsius or 298 Kelvin, a pressure of 1 atmosphere, and a concentration of 1 mole per dm³, is standard electrode potential. Now, the electrode potential of a single electrode cannot be measured directly, which means that two electrodes have to be connected together for you to measure their potential difference. You cannot determine the electrode potential of a single electrode. Instead, the electrode has to be connected to another electrode to form a complete cell, and then the potential difference between them is determined. Usually, if I want to determine the potential difference of, or if I want to determine, for instance, the electrode potential of a zinc electrode or a zinc half cell, if I have ZnSO4 here, which obviously contains zinc ions, and I want to determine the electrode potential of this electrode, I will have to connect it to another electrode whose potential is known. Now, that other electrode whose potential is known is called the reference electrode. And in chemistry, what is usually used as the reference electrode is the standard hydrogen electrode. How is the standard hydrogen electrode prepared? The standard hydrogen electrode consists of the following. It consists of a platinum wire that is attached to a platinum strip, which is also called platinum black electrode, and then sealed in a glass tube and immersed in an acid solution whose hydrogen ion concentration is 1 mole per dm cube. And then hydrogen gas is bubbled into it through this opening. That hydrogen gas must have a pressure of 1 atmosphere. Now, when this happens, what you have is the standard hydrogen electrode. And after this has been prepared, there is going to be an equilibrium between the hydrogen gas that is adsorbed on the surface of this platinum black electrode and the hydrogen ions in solution. So the half cell reaction at the standard hydrogen electrode is this, where you can see that the hydrogen ions from the acid is actually in equilibrium with the hydrogen gas that is adsorbed on the surface of the platinum black electrode. That hydrogen gas that is adsorbed here comes from the hydrogen gas that is bubbled into this setup from here. Now, the standard hydrogen electrode has a value of 0.000 volts. So this is the value of the electrode potential of the standard hydrogen electrode. It is a constant value. Now, the standard hydrogen electrode here can function as a half cell. So if I want to find the electrode potential of another electrode, all I have to do is to connect that half cell with the standard hydrogen electrode to form a complete cell and then determine the potential difference between them. That is going to give me the electrode potential of this half cell. So this is why I said that the electrode potential of a single electrode cannot be determined experimentally. That it has to be connected to another electrode whose potential is known. And that other electrode whose potential is known is the reference electrode. And what is used as the reference electrode in chemistry is the standard hydrogen electrode. So I want to believe that this basic explanation of what electrode potential is and the standard hydrogen electrode is clear. Thank you very much for watching, and see you in the next lesson.